Imagine plunging into the deepest, darkest trench in the ocean, a place so alien, so untouched by human hands, that the creatures lurking there seem almost otherworldly. The water is thick with shadows, the pressure so immense it could crush a submarine like a tin can. The deeper you go, the more reality warps. Bioluminescent creatures flicker like stars, thermal vents spew geysers of chemicals, and the silence is absolute. Now, imagine soaring past the edges of our atmosphere, drifting in the infinite abyss of space. Here, too, the silence is total. Stars burn billions of miles away. Gravity is a forgotten force, and the light of distant galaxies bends and shimmers just like sunlight, dancing on the ocean's surface. Two realms, one at the bottom of our world, the other stretching beyond our planet's reach. They seem like opposites, but what if I told you they're more alike than you think? The universe and the ocean. Two vast, unexplored frontiers that challenge our understanding of existence. They both defy human limitations, crushing pressures, extreme temperatures, and an environment so hostile that survival requires technology beyond our wildest dreams. But the similarities run deeper than just their mystery. The very physics of these two realms seem to mirror each other. The way water moves in deep-sea currents isn't so different from how cosmic dust swirls in the vacuum of space. The way black holes warp light and matter mirrors, the way whirlpools pull everything into their center. Even the strange alien-like creatures of the ocean's depths, glowing, shape-shifting, surviving where no life should exist, remind us of the bizarre exoplanets and celestial phenomena we're only beginning to understand. But how deep does this comparison go? How can the crushing depths of Earth's oceans reflect the boundless vacuum of the universe? And more importantly, what does it mean for the future of human exploration? Let's take a step back. You've probably heard the famous statistic: over 80% of the ocean remains unexplored. That means that right here, on our own planet, there exist mountains taller than Everest, valleys deeper than the Grand Canyon, and ecosystems teeming with life, none of which we've ever seen. Yet we have stunningly detailed maps of Mars, Venus, and even some of the moons of Jupiter and Saturn. It seems paradoxical. How could we know more about distant planets than the very world beneath our feet? The answer lies in technology. Light can pass through space, allowing telescopes to capture images of distant galaxies. But in the deep sea, light disappears within the first few hundred meters. After that, it's an abyss of pure darkness, where traditional cameras and sensors become nearly useless. That means the ocean is, in many ways, just as challenging to explore as outer space. Submersibles that venture into the deep must be built to withstand pressures thousands of times greater than what we experience at sea level, just like spaceships must be engineered to survive the vacuum of space. Astronauts and deep-sea divers wear strikingly similar suits, designed to provide life support in an environment where even a small breach could mean instant death. And then there's the question of alien life. When we imagine extraterrestrial beings, we often picture humanoid creatures with arms, legs, and intelligent eyes. But if we truly want to understand what alien life might look like, we should be looking at the deep sea. Giant squid with tentacles longer than a bus. Transparent fish with eyes that point upward through their own skulls. Creatures that generate their own light, like living stars in the void. If these beings can exist here, on Earth, why wouldn't similar extreme forms of life exist on water-rich exoplanets or beneath the ice-covered oceans of Europa and Enceladus? Before we unravel these mind-blowing parallels, let me ask you something. Have you ever wondered why we feel such a deep, instinctual fear of the unknown, whether it's the vast emptiness of space or the inky depths of the sea? Perhaps it's because deep down we recognize that both are places we were never meant to survive. They exist outside the realm of human experience, and yet we're drawn to them. Something in us compels us to explore, to understand, to push beyond the limits of our world. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. Now, let's take the first step into the abyss. The deeper you go, the stranger things become. In the ocean, the first 100 meters are familiar. Sunlight filters through the waves. Fish dart between coral reefs, and the world still feels like ours. But go deeper, and reality begins to change. Colors fade as red, orange, and yellow vanish into darkness. The water grows colder, denser, and eerily silent. Past 1,000 meters, the twilight zone begins, where the last traces of sunlight die, and life becomes something unrecognizable. Now, imagine drifting past the outermost layers of Earth's atmosphere. At first, space seems not too different from a high-altitude flight. Blue skies fade into a deep indigo, and you can still see the curve of the planet below. But keep going, and suddenly, the world you knew is gone. The sky turns black, the air disappears. The only sound is your own breath inside your spacesuit, and in all directions, an infinite abyss where light itself is swallowed by the void. The parallels are undeniable. Both the deep sea and deep space begin with a gradual transition, shifting from the familiar into the unknown. Both exist as layers, where each step deeper brings harsher conditions, stranger physics and life forms, if they exist at all, unlike anything we can comprehend. But perhaps the most shocking similarity between these two frontiers is the crushing, inescapable force of pressure. We often think of space as a place without pressure, a perfect vacuum where astronauts float weightlessly. But space is extreme. In its own way, the human body is built for Earth's atmospheric pressure, which is why the second you step into space unprotected, your blood begins to boil. Literally. Without pressure, liquids in the body turn into vapor, lungs collapse, and consciousness fades in seconds. That's why spacesuits are essentially portable environments, keeping astronauts pressurized and alive. Now, let's reverse the scenario. Dive into the ocean and pressure works against you in the opposite way. Instead of a vacuum, it becomes an overwhelming force, one that increases with every meter you descend. At the surface, the weight of the air above you is about 1 atmosphere. At 100 meters down, the pressure is 10 times greater. At 1,000 meters, it's a crushing 100 times what you feel on land. Go even deeper, into the Hadal trenches, places like the Mariana Trench nearly 7 miles down, and the pressure reaches a staggering 8 tons per square inch. That's the equivalent of an elephant standing on your fingernail. Under these conditions, anything not built for survival is obliterated. Traditional submarines would crumple like tin foil. Unprotected divers wouldn't just drown, they'd be crushed instantly. And yet, life persists. Somehow, creatures have adapted to exist under these unimaginable extremes. There are deep-sea fish with gelatinous bodies, capable of withstanding thousands of pounds of pressure without bones or air-filled organs to collapse. There are microorganisms that thrive near hydrothermal vents, feeding off chemicals instead of sunlight. Even stranger, some of these life forms resemble theoretical aliens, beings we expect to find on icy moons or distant exoplanets. Consider Europa, Jupiter's frozen moon. Beneath its thick ice shell lies a vast ocean, one that could be over 60 miles deep, far deeper than anything on Earth. And yet, scientists believe it could harbor life, possibly similar to the strange organisms we find around Earth's hydrothermal vents. Or take Enceladus, a moon of Saturn, where geysers spew plumes of water vapor into space, hinting at an ocean hidden beneath the surface. In many ways, studying Earth's deep sea is our best chance at understanding the alien oceans that might exist elsewhere in the cosmos. But pressure isn't just about survival, it's about technology. The vehicles we send into these extreme environments share striking similarities. A deep-sea submersible like Alvin, used to explore hydrothermal vents, is a thick, pressurized sphere designed to withstand crushing depths. A spacecraft like Voyager, which has traveled beyond our solar system, must be equally self-sustaining, capable of enduring the brutal conditions of interstellar space. Both rely on extreme engineering. Both are isolated from the outside world, carrying their own oxygen, power, and life support. And both remind us that whether we explore the deep sea or deep space, we are fragile beings, traveling through environments never meant for us, Yet despite these dangers, we keep going, we keep searching. Whether it's the blackness of the deep or the blackness of the void, something about these unknown worlds calls to us. Is it curiosity, the drive to conquer the impossible, or is it something deeper, a primal recognition that, in some way, these extreme places are reflections of our own world? Perhaps the greatest mystery of all is what still lies undiscovered. In the farthest depths of the ocean, where sunlight has never touched and the water pressure is so immense that human bones would shatter in an instant, life still thrives. Strange, alien creatures, some glowing, some transparent, some with bodies so soft they seem to defy the very concept of structure, move through the abyss, perfectly adapted to the crushing darkness. Now look to the skies. The universe, too, is filled with places of unimaginable extremes. There are planets where the rain is molten iron, where winds howl at thousands of miles per hour, where entire worlds are locked in eternal darkness. Yet, even in these impossible conditions, the question lingers. Could life still exist? If there's one thing the deep sea teaches us, it's that life is astonishingly resilient. It doesn't just survive. It thrives in environments we once thought were completely uninhabitable. For centuries, humans believed that nothing could live in the ocean's depths. After all, how could life exist without sunlight, without warmth, without the gentle embrace of a surface world teeming with energy? And yet we were wrong. In the 1970s, when scientists sent the Alvin submersible down to explore hydrothermal vents in the Pacific Ocean, they expected to find barren wastelands. Instead, they found entire ecosystems, massive tube worms taller than a man, ghostly, white crabs, fish with translucent skin and creatures that shimmered with bioluminescent light. These organisms weren't feeding on sunlight, they were feeding on chemicals, thriving in places that should have been lifeless. Now take that idea and expand it beyond Earth. If life can exist in the deepest, darkest trenches of our own planet, then why not on the icy moons of Jupiter and Saturn? Why not in the underground oceans of Mars? Why not beneath the thick, toxic clouds of Venus, where the crushing atmosphere is not so different from the depths of our own sea? The ocean, in many ways, is a testing ground, one that forces us to rethink our assumptions about where life can emerge. But it's not just life that draws parallels between the deep sea and space. It's the way these environments behave, the very physics that govern them. Take black holes. These cosmic monsters warp space and time, pulling in everything, even light itself, with an inescapable gravitational force. Now compare that to a whirlpool in the ocean, a vortex of spinning water that drags anything caught in its grasp down into the depths. Scientists have found that massive oceanic vortices behave in ways eerily similar to black holes. The mathematics of their motion, the way they trap particles and energy, the way they influence their surroundings, it's all strikingly familiar. Some physicists even suggest that studying ocean currents could help us understand the swirling, chaotic physics of space-time around a black hole. And there's the concept of bioluminescence, one of the ocean's most breathtaking phenomena. Imagine drifting through the deep sea, surrounded by creatures that glow like living stars. Some use their light to lure prey, others to communicate, and some to disappear entirely, blending into the starlit surface above. Now look to the night sky. The cosmos, too, is filled with glowing wonders. Pulsars, dead stars that spin at incredible speeds, emit rhythmic flashes like celestial lighthouses. Nebulae shine with the colors of ionized gases, their tendrils stretching across light years. Even exoplanets, distant worlds orbiting alien suns, sometimes reflect and scatter light in ways reminiscent of bioluminescent waves rolling onto a dark shore. The more we study the ocean, the more we realize it is not just a body of water, it is a model for the cosmos itself. The crushing darkness of the abyss is not so different from the interstellar void. The way creatures navigate the deep, sensing their environment through vibrations and electromagnetic fields, is not so different from the way planets, moons, and galaxies interact through the invisible forces of gravity and magnetism. And yet, despite everything we've learned, both the ocean and the universe remain largely unexplored. It's almost poetic. The two greatest mysteries known to humankind, one beneath our feet, the other stretching into infinity, remain, for the most part, beyond our reach. The question is, which will we truly understand first? For centuries we have gazed up at the night sky, dreaming of distant worlds, of alien oceans, of uncharted frontiers beyond the reach of our own small planet. And yet, beneath our feet, just miles below the surface, lies a realm just as alien, just as unexplored, just as unfathomable. The universe is an ocean, and the ocean is a universe unto itself. It's a strange paradox. We have sent spacecraft beyond the solar system, peered into galaxies billions of light years away, and mapped the surface of distant moons in exquisite detail. And yet, over 80% of Earth's own ocean remains unexplored. We know more about the surface of Mars than we do about the deep trenches of our own world. Think about that. Right now, there are entire mountains, valleys, and ecosystems, hidden beneath the waves, places no human has ever seen. There could be species that have lived for millions of years, creatures that have never encountered sunlight, never known the world above. To them, the ocean is the universe. And in a way, the same could be true for us. Imagine if right now we are like deep-sea fish, swimming in the familiar, comfortable world of our own planet, unaware of the vastness beyond. Imagine if intelligent life exists out there, watching us from a cosmic ocean so vast, so deep, that we are nothing more than microscopic specks drifting in the tide. What if we are the ones living in a trench, looking up at a universe we barely understand? The more we explore, the more we realize how little we know. And perhaps that is what makes the unknown so compelling. Whether it's the depths of the sea or the depths of space, something about these great mysteries pulls us forward. Maybe it's the primal instinct of an explorer, the same instinct that led ancient mariners to cross the open ocean, that drove early astronomers to chart the heavens, that compels us to keep searching, keep pushing, keep asking, what's out there? But the most fascinating part of all, we are living in an age where these questions might finally be answered. Right now, robotic submersibles are diving deeper than ever before, mapping the seafloor with cutting-edge sonar, searching for life in the most extreme environments on Earth. At the same time, telescopes like James Webb are peering into exoplanet atmospheres, looking for signs of alien oceans, scanning the skies for the faintest whispers of life beyond Earth. And if life exists, whether in the crushing depths of an alien sea or in the freezing darkness of space, these next few decades may be the moment we finally find it. So the question remains, where will we find it first? Will it be here in our own unexplored abyss, or will it be light years away, hidden beneath the ice of an alien world? Maybe, just maybe, the answer has been staring at us all along, in the bioluminescent glow of a deep-sea creature, in the swirling chaos of an ocean vortex, in the way our own planet whispers its secrets through the currents of water and time. One thing is certain: we are explorers by nature. And whether our journey takes us to the bottom of the sea or the farthest reaches of the cosmos, we are only at the beginning of a story far greater than ourselves. So now, it's your turn to explore. Like, share, and comment below. What do you think? Will we find alien life in the deep sea or out among the stars? Let's keep the conversation going, because the more we question, the closer we come to answers. And who knows? Maybe one day in some distant future, we will look back at this moment and realize it was the first step into something truly extraordinary.